knows what's going to happen.
Professor Robertson,
are you looking? Yes.
Just a quick question. If we aren't going to take
Yes.
test 5, do you want us to let you know, or we just don't show up?
Just don't show
Okay.
up. I'll assume that you don't show up is you're totally entitled to do.
Got it. Thank you.
Right. So the test 5 is on hypothesis testing. There are 4 topics and there's 4 questions. So you're going to get 1 question, hypothesis test on single proportion, question on hypothesis test with the difference between 2 proportions. When you get that one, it's going to be the P1 hat, Q1 hat over N1 plus P hat 2, right? The guys that you were taught, right? None of the weird fooled stuff, right? So it's going to be that. And then you're going to do a single mean and the difference between 2 means. And when you do the difference between 2 means, the degrees of freedom are going to be the smaller of the 2 minus 1, right? Not any weird general formula that you might have got in your homework. Are we good with that? We're comfortable. 4 questions. Now, if you're wondering what Nikia was mentioning about test 5, if you've got 4 good tests and you think that this one's not going to be any better than the 4 you've got, you can choose not to turn up. I only count the best 4, so test 5 is optional. If you've missed a test, you better do test 5, because that 0 that you've got right now is at least going to turn into something, and hopefully something nice and big, and that will help your grade. Looks like Diane's trying to come in now. She bounces out and in. What else? We've already talked about, I think. I told you how to figure out what you need to get in the final based on your raw data again. Told you that yesterday. Okay, so we're good with that. You know that can change. If you do test 5 and it ends up boosting your grade, then the numbers that you need in the final will hopefully be a lot less than what they should be. And that is about it. So let's, has anybody got a topic? I'd rather you say, can we do an example of, but if not, I'm going to do some hypothesis testing. So I feel like
I think that's the same that I was going to ask for. 13A, I was going to ask if you could work at least one from the homework in 13A, but I think that's the same topic.
Right, that'll do. So we'll start then with a hypothesis test. For a single mean. Give me a few moments and I'll find a question. Don't know what that's doing now, that's my calc. Okay, where are you? There we go. Single mean is, must be in the next page. Oh, it is. Hypothesis testing, difference, single mean, 13A. Okay, view. Just checking in. Gotcha. Let's find one then. We need a whole story. Okay. Question 10. A cell phone company knows that the mean length of calls for all its customers in a particular city is 9.8. So 9.8 is the fixed value, right? We're assuming that that's status quo. The company is thinking about offering a senior discount to attract new customers. So if you're over 60, you'll get it for this price rather than that price. but they only want to do so if the mean length of calls for customers who are seniors, which in their world is 65 or over, is lower than the general customer pool. Okay. So the only way to identify seniors is to conduct a survey and ask them whether they are over 65. Using this method, the company contacted a random sample of 100 seniors and recorded the length of their last call. Okay, so they're basically just giving you the details of where they got their numbers from. And it was 100 old fogies like me, and 8.9 minutes. Okay, and what do we know? Suppose if the standard deviation were again 8.9 minutes and 10 minutes. Okay, that looks like a 2-point deal. So why do I need that? And I need the standard deviation of 10. They told me some numbers I didn't need to know. Yeah, so that guy, 100 tips. So we're going to do a hypothesis test to see whether old people, on average, is less than the normal 9.8 minutes that people typically do on a call. So the null hypothesis and the alternate. The null hypothesis is that it's still 9.8, and the alternate is that it is less than 9.8. So when you do null and alternate for singles, it looks like that. A different question, but you know the ones where you're comparing two groups? The null hypothesis is the difference is 0, and the alternate hypothesis would look like that. You see, that would be the difference between two population means. But this is a one deal. So one of them, the 9.8, is considered the fixed value. And now we're trying to see, is there evidence that old people phone less than that? Well, superficially, would you agree it is less? About a minute, roughly. So now we need to find all the numbers that go with that set of data. So the standard error of the mean is S over the square root of n, which is 10 over, oh, come on, that's, oh, okay, that's 1. It's a surprisingly nice number. Can you actually see this? I should have checked. Yes, you can, right? You're actually seeing this. All right. So when we're talking about the test statistic, when you do means, isn't it a T score, not a Z score? Z score is for proportions. T score when it's means. So the test statistic is a T score, and it's X bar, take away mu, over the standard error. In this case, we are looking at 8.9, take away 9.8 divided by 1, and this ends up being negative 1.8. So when they say test statistic, they mean the T-score. If it's a difference in proportions, won't the test statistic be called a Z-score, right? It'll have its own formula. Now, the T-val, also, that is the number that you stick in the box that says, what's the test statistic? So we get an echo here. Now, the P-value is the probability that you get a T-score less than negative 1.8. Why do I know it's less than this number, not more than?
I have a question. How come it's negative 1.8?
8.9 take away 9.8 is negative. It isn't negative, nothing point 1.8 at all.
Should be half that, right? So just
It's not that.
negative 0.9.
Yeah, it's negative 0.9. I can't count. Yeah. The reason I wrote that down is that's what they wrote, but I know what they did there. They just doubled the score, which is no good reason for them doing that, but whatever. Right, now you want to do the t-score on this. Wouldn't we just go into salt and pick the t-distribution and do the rest? Right. Now, yeah, you got me puzzled there. Why is it 1.8 test statistic? Did I do anything weird? No, no. Did they have another number up there? Because they gave me two numbers. I wonder if that's anything to do with it. No. Is that enough, or do I need to keep going? I'll tell you what their p-value is. And the p-value they got is 0.0363. Right, so if you did it, that's what you would get. Right, so to finish this question then, you ask yourself, is the p-value less than alpha? And now I have to go looking for where the alpha is. Oh, WebAssign, you drive me crazy. I'm scanning through the question and oh, there it is. They had it hidden. Right, it was 5%. I was saying, I can't find it. So the p-value, which is this fella, no, as a decimal, it's that. I like percentages. And the answer is yes. It is less, right? 3.63 is less. So you would be saying, what was the sentencing choices? Reject H not. There is sufficient evidence to show that old people are on the phone a shorter time than new ones. That's the only one that bugs me, that they doubled that, but there's no good reason for you to double that, not that I can see. But thankfully, everything else was fine, so. Weird. Let me pick another hypothesis one. I'm going to pick a single proportion.
Professor. So for
Yes.
that, on 13A, the hypothesis test for
Yes.
single mean, as I started doing that one, I noticed that even when I was entering the test statistic, like I'm totally fine with how you're teaching it, and I understand everything about it, but every time I do it, and I've tried it other ways, it just always says that the test statistic is wrong still for this, even for 13A. So I'm not really sure.
Well, I know I fixed the difference ones in proportion.
Yes,
because they pulled it and never told me. I do not know why that one was doubled yet. I can't think of a good reason for it. Of course, I may have screwed up in my calculation, but I mean, that's such an easy calculation. I can't really see where I screwed up.
I know, and that's how I feel with all my stuff. I go through it so slow, and then every time I enter it, I don't know. Honestly, maybe it's just me, but
I feel your pain. I think it's too late for you lot. I think what I'll do when I teach this again is, for this chapter in particular, I'm just going to be really careful about the questions that I choose so that they match up with the data the way we want it to. The only thing I can think of here is that somehow they used the other information. But I don't know how they could use it. No. Well, let me do something. You've got me. I didn't realize there was a problem with that one. So I've got the solution key in help. I'm going to go down and see what they were expecting to see in question 10. Yeah, let me show you what my problem is. And it's kind of connected to yours. They only tell me when I go looking what the answers were. So do you see here how they've doubled that in negative 0.9 with no indication of why they did it? So I don't know what they were up to, but if you use that guy, this is the fella, and then reject is fine and all that stuff is okay. Oh God, look, there's my negative 0.9. So they're contradicting themselves. They're saying that the test statistic and the p-value were found to be negative 0.9. Yet up here, they didn't call it negative 0.9. I think the guy was drinking Bushmills. When they did the entire chapter, he was in a drunken stupor.
Yeah, that's kind of, I was having problems with all of these ones on this one with the test statistic and stuff.
I'll just go through everybody's. I think I don't know what to do. What I'm definitely going to make sure is that you don't get penalised because of things that are beyond your control. Well, you may just do your questions the way I described them and we'll be fine. And that's the answers I'm looking for. So that's the way we're going to do it. I wish I could get into what they were doing and then I could come up with it. I found out what they were doing in the difference in proportions. They were just doing a weird version of the pooled formula. But these are the same people who think 98% is a good confidence interval. So who knows what they were up to. Right, I'll have a look at it and fix it. The fixing might simply just be to make the questions that have problems 0. Right, and so that you don't lose any points, and then just add the others up so that you get 100. I think that's
maybe
probably
all
the best
of the test statistics they're asking for is just 2 times what the real answer should be for whatever reason.
Which we haven't figured out why yet, but I guess. The only time that you could do that that would make sense to me would be in a 2-tailed test. You might want to double it there, but even that would make sense. I would double a p-value. That would make sense, but not a test statistic. Now, you can pull data, but you can only pull data when there's 2 samples, so it can't be that.
I don't know.
I don't want to say it's a mistake. Right. You were saying, David.
Oh, no, I was just saying I actually got this one right somehow, but I can't find my notes on where I did it, so I can't actually tell you, but I did get it right.
Maybe you got it wrong the same way that the person who did the solution got it wrong. I doubt it. Okay, I'm not going to dwell on that. The questions that we are going to do on hypothesis testing, the way that I'm doing them is totally correct. I'm not going to change my mind just because they do something weird. When you do your test that you get on Monday, it'll be based on the way I do it. And when you get any questions in the final, it'll be based on the way I do it. So you won't have to worry about numbers doubling for no apparent reason, or things being pulled when they probably shouldn't be. But at least that'll make the big points, right, tests and finals, that'll make them fair, and there won't be any weird stuff going on. What do you want me to do next? We should finish on positive things that actually work rather than issues with that one. Web design's been pretty good. I think hypothesis testing and me aren't happy, but apart from that, they've been pretty good. So I'm not too worried about anything else. Well, let's just check. You're the ones that actually do it. When you did the confidence intervals, did they come out okay? Barring maybe rounding off, there wasn't any major hiccups. Can you remember doing the confidence intervals? Anybody remember the answers? Did they come out okay?
From what I've done with
Yeah,
the
got nuts.
intervals, they were fine to me.
Right, so that's kind of an extra irritation to me, because if you look at the formulas that we use for confidence intervals, have you noticed that the standard error formulas are the same standard error formulas that you use on the bottom of your T and Z scores? Right? It's the same, you know, square root of P1, Q1, all that stuff. So why in hypothesis testing are they making life so awkward? I'm going for Bushmills. Right, oh, let's do a confidence interval. That's a good idea. What do you want? Single mean, difference between two means, single proportion, difference between two proportions. Let's finish on something cool. What kind of confidence interval do you want?
Difference between two means.
Okay. You did not know this because I've just made it up. But they got 100 men and they weighed their brains and found out that on average they weighed 20 pounds. And that the standard deviation was 4 pounds. And they got 200 women and they weighed their brains, and their brains were 25 pounds because we all know that women are much more intelligent than men, right? Now, do you notice that you can be sexist against males and it's totally okay? If I changed that storyline, I would be in so much trouble with my wife. So we're doing it this way. And we would like to know, what do you want, a 90, a 95, or a 99? Because I refuse to do a 90 yet. 90, 95, or 99? Which one, which confidence interval do you want?
$99.
99. So we are going to do a 99% confidence interval. And it's going to be X1 bar, take away X2 bar. So males, females. Plus or minus the magic, the magic T-score for 99 times the standard error of that. Right. So there's a few bits and pieces to get. I guess I'll do them over here. The version of the standard error I'm going to use is the two independent groups. I don't think you can be, you can assume that you can pull this data. So S1 squared over N1 plus S2 squared over N2. In this case, it's 4 squared over 100 plus 5 squared over 200. Square root of 42 divided by 100 plus, no, I said 42 there. That's 4 squared. So the square root of 16 divided by 100, add 25 divided by 200. And I am looking at 0.53. Okay, also 16 over 100, 25 over 200. Yeah. I need to find this guy. And this guy is going to be for degrees of freedom. And the degrees of freedom I'm going to use are 99. The smaller of the two, take away 1. If you were trying to be really clever about that, there is a formula in the textbook where you use both datas, and it's ridiculous and doesn't make a lot of difference anyway. So the number that I need is actually in a file on Canvas, which is what I'm looking for right now. And here we go. And it's called T-distribution table. And let's jump over and see what it looks like. So this is kind of what you would be doing in your own test if you were doing this question. Right. So make it a little bit bigger. So I want 99, so I'm going down this column, and sorry, I'm looking for 99, and it's 99 degrees of freedom, so I'm going down this column. I don't have a 99, so I'm going to pick this guy here, 2.63. And we are good. Get back over here and continue the question. So all the magic numbers we have got, if you take 20, take away 25, plus or minus 2.63, standard error 0.53, you get -5, give or take, here we go, 2.63 times 0.53, and it's give or take 1 point. Let's just call it 1.4, make my calculations easier. And if you take it away, it's -6.4. If you add it, it's -3.6. So our 99% confidence interval for the difference between men and women's brains is this interval. All of these numbers are negative. What that is telling me is that, can't we say that this is evidence that men's brains are smaller than females? And the argument is that if the interval only has negative numbers in it, doesn't mean the difference is negative, and so males have to be smaller than females. Right. So you get a question like, is there enough evidence to prove that males' brains are smaller, lighter than females? If I had got an interval and it looked like this, would I be able to say that that's evidence that males are smaller brains than females? Would this interval be proof of that? And because 0 is contained in the interval. And you could have, we didn't get it, but can you imagine you might have got data that looks like this? If this data had happened, wouldn't that be proving that males had bigger brains than females, heavier brains? So when you're looking at the interval of the difference between them, all negative and all positive are evidence of the first one less than the second, or the first one bigger than the second. An interval that contains 0 is no evidence of anything. It could be either way. Are we good with that? Without going through the whole question, imagine I did a single confidence interval on just the males. And let's just say that the answer I got was 17 to 23. So this is just a 99% confidence interval on males. This interval you would read differently, because you don't get a question, is something bigger or less than something else, because there isn't a something else. What you tend to get here is there evidence that it's more than 15? Well, if all the numbers in the interval are bigger than whatever this number is, then yes. You could have, is there evidence that it's less than 25? Well, if everybody in the interval is less than 25, you can say yes. But if it says something like more than 18, or say less than 20, if they ask, is there enough evidence in this interval to prove these two? The answer is no, there isn't evidence for that. More than 18 doesn't work. Couldn't the answer be 17? Right, that's possible. Could the brain be less than 20? Well, it might not be. Couldn't it be 22 and 23? So the average brain size couldn't be. So if any of these numbers are in the interval, there is no evidence. So that's how you would look at an interval and look at it for evidence of the difference between them, if it's 2, or bigger than or less than some given number, if it's 1. You're looking intently, David. Is that a good sign, or are you thinking about a question?
I'm good.
It makes sense? Can already formulated that in your brain? Doesn't proportions have the same thing? Right. If all the numbers are negative, doesn't that mean the first proportion is less than the second? If all the numbers in the interval are positive, it means the first thing is bigger than the second. And if you have an interval that's negative this to plus that, right, it contains 0, then that's a no evidence, which is essentially the same rule for here. Here's one. Suppose I did, are you going to win the election thing? Right, and we did our analysis. And the answer I got was 49.5% to 50.2%. So this is our predictor on the percentage of people who are going to vote for the Republican. Does this interval guarantee that the person's going to win the election? Would that interval mean he is going to win the election? If there's only 2 candidates, we'll assume that's true. What's it telling us? It's telling us there's not enough evidence. Too close to call. If it's that number, he just won. But if it's that number, didn't he just lose? Because if he gets 49.5, didn't the other guy get the rest? Which means he won. This would be an interval where he won. This would be an interval where he lost. And this is an interval where you can't tell. To win an election, don't you need more than 50% of the vote? And that's essentially what I was using. More than 50, you win. Less than 50, you lose. If 50 is in the interval, see, it's not 0 now. If 50 is in the interval, doesn't that indicate that it's too close to call? You don't know. Right. Any other questions? Right, note to self, once I leave you, I'm going to go in. Are every single one of the hypothesis chapters questions, are all of them causing problems? Or is it only, I know that I fixed the difference in two pair. Was the single proportion hypothesis questions, were they causing trouble, or can I leave those guys alone? Were you getting the right answers and it was matching their answers?
It worked for me.
It worked, okay.